At this moment, I would like to go to the next part of our program. So now it is time to hear from our distinguished panelists. The moderator for today's panel is Dr. Brian Weiss. Now, Brian is a mechanical engineer with NIST, the National Institute of Standard and Technology, and Brian is the leader of the MDP4MO project within the engineering laboratory at NIST. So our other panelists today, it's going to be Matt Malloy from BMW, who you met before, Stefan Friedrich from NewScale Robotics, Silas Neal from Universal Robotics, and of course, Ben Rand, who you met before. Angelo Lalo will also be joining us, our keynote who you just heard from. So can all the panelists please join me and Brian on the main stage? So Brian, will you please take it away, please?
Good morning, everyone, and thank you very much, Everton. As Everton mentioned, my name is Brian Weiss. I'm a mechanical engineer from the National Institute of Standards and Technology, and we've lined up a diverse slate of panelists with a unique perspective today on robotics and automation. So the goal of today's panel is to give you, the audience, the opportunity to better understand how some of your fellow New Yorkers are advancing robotics and automation within their respective roles in the manufacturing ecosystem. Given that this panel is for you, your questions are most welcome. And so there are multiple ways to get your questions across. Written questions, if you prefer your questions to be asked by myself, please type your question in the Q&A window, and the targeted panelist or panelist you'd like the question asked to. If you prefer to ask your question verbally, no problem at all. Please indicate in the Q&A window that you have a question to ask. One of our team members will unmute you when the opportunity presents itself, and then you can ask the question. So our goal is to cover as many of the questions as we can during the panel. If we're unable to get to your question, or if you have a follow-up question or the panelist's response was relatively brief in the interest of time, I encourage you to network with that panelist or panelists during the latter portion of today's event. So the panelists and I have questions prepared if the audience is a little slow to get moving in terms of generating your questions, but our goal is to answer your questions first. Before I hand it off to the panelists for introductions, I'd also like to thank FuseHub for inviting me today to moderate today's panel. And a big special thanks to Kim Lloyd and Ben Weinberg for monitoring the incoming questions. So before we jump into the Q&A, we're going to give each panelist just a few minutes to introduce themselves. Some of the panelists have already spoken to you this morning, so their introductions are going to be relatively brief compared to those folks you have yet to hear from today. So looking at my batting order, I'd first like to call Matt Malloy to the virtual microphone from Buffalo Manufacturing Works, just to give a little bit more perspective on where he's coming from in terms of robotics and automation. Matt, the floor is yours.
All right. Hey, good morning again, everybody. So I was one of the ones that talked for a few minutes earlier, so I'll keep this really quick. So my name is Matt Malloy. I run our automation program over here at EWI, and also known as Buffalo Manufacturing Works here in Buffalo, New York. We do a lot of work with small and medium manufacturers across the region and in other places, trying to help them understand where and why they should add new advanced manufacturing technology. A lot of that around automation, but other technologies as well. So we're definitely here to help you kind of navigate that journey. All right.
Excellent. Thanks a lot, Matt. Next up in the batting is Stefan Friedrich from NewScale Robotics. Stefan, if you please.
Thanks, Brian, and thank you to FuseHub for hosting the event and having us here. So I'm Stefan. I'm the product and marketing manager at NewScale Robotics. We're based out of Victor, New York, which is about 20 minutes or so outside the city of Rochester. NewScale Technologies is the parent company for NewScale Robotics. And in general, we focus on manufacturing high precision motion systems, usually for industrial and OEM manufacturers throughout the world. And in 2018, we launched NewScale Robotics, and we work closely with manufacturers and distributors to identify part handling and inspection automation applications. So usually we're working with our partners and customers to bring together technologies in both robotics, but also metrology and gauging to solve customers' applications in the inspection space.
Excellent. Thanks a lot, Steph. So our next panelist to introduce themselves is Silas Neal from Universal Robotics. Silas, the virtual microphone is yours.
Thanks, Brian, and certainly a thanks to FuseHub for having us today. My name is Silas Neal, and I'm a channel development manager for the Northeast here at Universal Robots. My role is to work with our distribution partners, our systems integrator partners, and then our whole ecosystem of UR Plus partners, which is our application kits and peripherals that work with our product line. So I work behind the scenes supporting that variety of different channels. Universal Robots is based in Denmark and was created many years ago as an idea by a couple of Danish grad students who wanted to automate a pizza shop. And knowing that they couldn't do that with traditional fixed automation, they started working on a force and power limited robot, thus cobots. We sold our first robot in 2013. To date, we've deployed about 60,000 robots globally. We have approximately 50% of the market share in the collaborative robot space. And the vision of Universal Robots is to create a world where people work with robots, not like robots. Thank you for the introduction.
Excellent. Thanks a lot, Silas. Now we're going to move on to Ben Rand from Insight. Ben, take it away, please.
Thanks, Brian. Hello again, everyone. You already heard that I was president of Consulting, the Western New York MEP. We're based in Buffalo, right across the hall from Buffalo Manufacturing Works. My background is manufacturing. I ran manufacturing businesses for US Filter, building water purification systems, and for CFAR Filtration, which was technical textiles infiltration applications. I actually hired Insight Consulting to do some work for me. And as the old saying goes, was so impressed that when they approached me about joining the company, I jumped at the chance. Our role is to provide competitive improvement for small and mid-sized manufacturers. We do that by offering a range of consulting services from strategic planning, sales and marketing, to process improvement and quality management systems. We also partner with folks like Buffalo Manufacturing Works who can bring technology to the table and other skill sets that we don't happen to have in-house. So we're excited to be here and to tell you a little bit about how we've worked with Buffalo Manufacturing Works. Thanks, Brian.
Thanks a lot, Ben. And our last panelist, who actually you just heard from, Andrew Lawler from BorgWarner. Andrew.
Hi, good morning. Thank you, Brian. So obviously you guys just heard from me for about 15 minutes in my background. So I'll keep this very brief. I'm just looking forward to your questions. And of course, we have a lot of experience here on Ithaca campus that I hopefully can share with you today.
Excellent. Thanks a lot, Andrew. And before we get right into the Q&A, and I do see some questions that are coming in the Q&A window, thank you very much. Again, quick reminder, if you want a question answered, feel free to type it in the Q&A window. We do ask if you want it directed at a specific panelist, please note that panelist name at the front of the question, and that way I can target it accordingly. If not, I'm probably going to pose it across the entire panel and ask one or two folks to respond. If you prefer to ask your question verbally, just throw in the Q&A window. You have a verbal question. A team member will unmute you when the opportunity presents itself, and we will give you the floor to ask your question. All right, our first questions have actually come in from John Gilmore. Thank you, John, for being the first up with questions. I see you have two questions in there, but I feel like this could be directed at two different people. The first question, my biggest question is mostly on data collection and decision-making automation, which definitely requires some machine learning and AI. Does anyone have experience with this type of automation and any suggested tips? So asking the entire panel, who would like to take a stab at this question?
I can talk to sort of data collection from the inspection side.
Please.
So yeah, so with what we do, usually we're automating gauging, like, so if you think about using a caliper or a micrometer, bore gauges, air gauges, things like that. Those are the type of tools that we automate at NewScale. So, we use collaborative robots from Universal Robots for most of our applications. And as we're gauging parts and collecting data during the manufacturing process, You can make some pretty simple decisions off of that. We haven't really deployed systems that use, advanced AI and machine learning like that, but it could be, you can make simple decisions where, let's say your part has a outside diameter of 10 millimeters and your tolerance is, 2/10. Well, if the part is within that tolerance window and it's an inline inspection process, as long as those parts continue to pass, you can keep running the process. And, then once a part fails, that's where some decision making can come in, where you can either stop the process and notify an operator that the machine needs to be serviced. You could dump the part into a failure bin, and then just continue the process as normal. Wait for 2 more parts to fail or whatever your threshold is before the machine needs to be serviced. And then there's some other, a little more advanced ways that you can use decision making. So one is, in addition to just pass-fail sorting, you could take a bunch of measurements on a part. Maybe you're doing something like a fitted assembly operation where parts that are within certain measured tolerances just fit together better in your assembly process. Well, usually you'd have like an operator sitting there with like a micrometer. They measure the part, whatever that critical dimension is, and they sort them into bins. It might be 10 bins, it might be 50 bins of parts of these different sizes. You can use a robot to do the same thing. You measure the dimension. If it's 10.5 millimeters, it goes into this bin. If it's 10.6 millimeters, it goes into this bin. You can get more precise than that, but those are a couple simple ways that you can use data to make decisions. And then another very simple example as well would be, if you have like a cylindrical part, using this highlighter as a sort of crude example, rolls down a conveyor to a single pickup point. We have a gripper that can measure parts. So if you grip this end and it's 12 millimeters, but if the part's in the wrong orientation as it rolls down the conveyor and this dimension is 11 millimeters, well, now you know that the part is upside down. So you can use really just a simple if-then command to say, if you pick the part up in the right orientation, continue the process as normal. If you picked it up in the wrong orientation, you know that you have to flip the part and then you can continue the process as normal. So those are a few examples that I have offhand.
Excellent. Thanks a lot, Stefan. So anyone else from the panel want to chime in, definitely from the machine learning and AI perspective with respect to it supporting data collection and decision-making automation?
Yeah, I'll jump in and say something too. I think so.
Please.
The data topic is becoming incredibly important, right? But it also differs a lot on what someone's looking for. So I think the first part of the question that came in, I think, is more clear cut, right? When it comes to what a lot of us kind of refer to as machine learning and AI in the automation world, some of that is pretty straightforward nowadays, right? If you're talking making decisions on the fly, measuring parts, whether it's mechanically, optically, laser profilers, all kinds of different ways, even things that are more exotic. If it's about kind of collecting that data and making decisions on the fly, that's pretty straightforward. And we could, or several of the people on this panel and others could point you to, say, good products that would do that type of thing. And integrating those isn't all that difficult. So I think that one's pretty well covered. And we'd be more than happy to talk and give you some guidance and suggestions if at any point if you'd like. The second one though is where it gets interesting, right? In the large amounts of unstructured data, and that's where there really is a lot of effort going on. Not so much in the automation space directly, but in everything surrounding it, because it's all about data right now. In fact, we have a team. Had I known that question was going to come up, I would have pulled someone different in here to take my spot. We have a small team that's actually working on that exact thing, right? Dealing with these large amounts of structured and unstructured data coming out of machine tools, large complex systems and things like that, and making those real-time decisions, but also figuring, how do you get that into the cloud? How do you get data back out? How do you do what you need to do with it? That part is, I'd say, less figured out, right? So if you're jumping into the collaborative robot space, addressing the first part, there's probably a pretty clear path. Addressing the large amounts of unstructured data part is going to require some development, and we could, again, try to point you in the right direction there if you need help, or at least give you some suggestions of companies that are doing that type of work.
Excellent. Thanks a lot, Matt. So actually, as Matt noted, there's a second part of that question. I definitely want to shift to that. Also from John. And then after we handle this one, I see more questions coming in. I'm going to direct the second question to Andrew, just by virtue of BorgWarner having grown over the last X amount of decades. And I am confident that you guys are probably handling a lot of data. Andrew, what's your perspective on tips in collecting large amounts of data that isn't well organized, whether you're going down the machine learning and AI path, or if there are other more conventional strategies that you have found successful in BorgWarner?
Yeah, thank you. So this is definitely something we're diving deep into right now, and I think is kind of our next big step. We have a lot of different softwares that we use to collect data, and for us, some of that data is our scrap data, uptime, process parameters, maybe how did a part run. We have lots of inline measurement systems as well. And then additionally on the chain side, we have some challenges on when we pre-stress the chain, we're putting a load on it, doing some basically a form of cold hardening. And we're trying to predict some of that. What is our final outcome? We use a lot of things, so like Tableau, if you've heard of that, or Click. So these are basically nice software packages that allow you to take a lot of unstructured data, and it's kind of like a pivot table on steroids. So it gives you that ability to slice and dice the data in a way that can, I'll say, make more common sense. And that's a way that you definitely can't necessarily automate it or do some form of machine learning if you don't understand it yourself, and if you can't make your own decisions based off of the conclusions of the data. So we try to use some of those. I mean, these all in the background have SQL databases. So we have a few people here that are really good at getting all the data into a database. There's Wonderware. There's all sorts of softwares out there that connect to your machines. And then we try to analyze it ourselves. Now, we're also working with Cornell University and their team. Luckily, being in Ithaca, we have access to that, and lots of students, PhD students and master's students who are trying to write their theses. So they're also trying to help us develop how can we use some of this data to predict and make decisions before it actually happens. So unfortunately, we're not there yet, but that's definitely our next big step. And definitely, John, if you wanted to talk further, stop by the table afterwards.
Excellent. Thanks a lot, Andrew. All right, so we're going to jump around a little bit in the questions by virtue of the questions that are teed up. Chris Coulter, we're going to get to your question next, but before we do that, I want to address the question that Albert Mangels presented. What are the similarities and differences between cobots and other conventional CNC machine tools, especially relative to factory floor workers? Silas, I'm going to give you first crack at this question.
Sure, that's a really good question. I like that one. I appreciate that. Certainly differences wise between CNC and the machine tool space and collaborative robots. Collaborative robots don't have any substantial power requirements. Single phase 120. That's it, right? So you can put them pretty much anywhere. The robot that I have behind me here in my office is a standard deployment robot that you'd see in a lot of manufacturing floors, and I definitely don't have a 480 drop here at the house. But the big thing is going to be mobility and flexibility, right? So you can move collaborative robots around throughout a facility to a variety of different processes with very, very quick recipe changeover. In a matter of 15 minutes or so, you can have it tending a lathe and then moving over to a sanding or a deburring application. So the flexibility piece is certainly one that's very noticeable. When we talk about similarities between the two, it's very straightforward, right? If you're looking at a lathe, one robot, one spindle, it makes it really straightforward just to take a human operator and remove them from covering a single machine and have them tending a number of different machines, right? Andrew spoke of that quite a bit earlier this morning. So it makes it really straightforward from that standpoint. And I think you can find quite a bit of uptime as a result.
Thanks a lot, Silas. Matt, anything to add to that before we move on to the next question?
Oh, I think those are all the key points. I mean, the moving them, not having a huge power requirement. Same as Silas is there. It's allowed me to take these robots to other places and plug them in and show them off and get people excited about them. And they're just quite easy to learn and get comfortable with. They're not intimidating, especially for someone who doesn't have a robotic background. You can hand them a teach pendant and, in 10 or 15 minutes, they can at least be doing some basic stuff with it and not feel scared. So.
Excellent. Thanks a lot, Matt. All right. So we're going to jump to Chris Coulter's question. Ben, I'm going to throw this one in your court. The question is, I'm interested to know rough costs for cobot implementation, not just the cost of the cobot, but the tooling, the fixturing, end of arm tooling, camera options, and other implementation costs, such as training. So please, Ben, share your perspective on this.
Okay, I'll do my best, Brian. Thanks. And thanks for the question. I think the great insight here is that the cobot itself isn't the end of the line for you if you're looking to implement these technologies. And all those other pieces have to be considered, as well as your work cell arrangement, your shop floor layout. And we've already talked about the fact that one big advantage of cobots is they can easily be transferred among different operations in your plant. So factor that into your thinking too, and into your costing. But in terms of the actual cost of cobots, I'm going to probably defer that one back to Matt, because I know he's constantly buying these things and probably has more updated information than I do.
All right, Ben, thank you.
And I better in turn refer that over to Silas, so I don't, say something wrong about somebody else's technology. But yes, we do buy a lot of them.
So Matt, do you want to say anything before we hand it off to Silas? Did you want to say anything about the elements beyond the robot itself from your perspective, and then we'll jump to Silas to get his perspective?
Yeah, sure. And there is a lot more to it, right? So we talk a lot when we talk about automation, right? Automation can mean something different to everybody, right? Sometimes it's a single robot. Sometimes you picture an automotive factory with stuff all over. Sometimes it just means automating how two pieces of software talk to each other, right? But usually when you say automation, people picture a robot of some kind. But the robot is really just the thing that moves something else around or does something else. It's a tool, right? It's not the whole solution. You have to think about all that other stuff. Nowadays, it's getting pretty easy to connect and integrate all of that other stuff into a robot system. And those things can cost, just as much, if not more than an arm. If you're talking, buying a small collaborative robot and then buying, a complex 3D vision system for it, that vision system may cost more than the actual robot itself, right? So it depends on what you're trying to do with it. But first and foremost, kind of going back to something in the beginning, you want to be really careful about your process, right? Think about your process first, right? Adding, we see a lot of people that want to just jump right in and say, hey, I just want to add a robot somewhere, and it's great and it makes it fun, but sometimes it's kind of ill-intentioned, right? It's trying to put a robot in to fix a process that doesn't work right is really just a Band-Aid. So you got to kind of think about those process aspects first. Spend a little money there if you have to. Make sure that's figured out and it works well. And then you can figure out the right type of technology, whether it's a collaborative robot, a traditional robot, whether it's a universal robot or a different brand. There's lots and lots of options out there.
Yeah, if I could piggyback on that for just a second, Brian, I think Matt makes a great point about looking at your process and thinking about that. And in particular, looking for simple, basic, low-cost solutions that can get the work done. You may think you need a 3D vision system, but if you can set up your tooling so that you can accomplish the same thing in a very low-tech way, that often proves much more robust and certainly more cost-effective.
Excellent. Silas, anything to add before we go to the next question?
Sure. I to Chris's question here, nobody likes the answer. It depends, and I certainly respect that. But it really depends a lot on what your specific process is, right? We've done so much in the, say, subtractive metal manufacturing space that we can come up with a pretty good window for what it costs to simply run a lathe lights out. Same thing within metal fabrication on the welding side. We have a number of pre-engineered solutions that if they work, we can give you a rough cost, but a lot of it does depend on what kind of resources you have internally. Is it something you plan to tackle yourself and do the self-implementation? Do you want to do it with a little bit of a help from a local distribution partner, or do you want a full turnkey system that's simply rolled right up to your production floor ready to go? So there are a lot of variables, and to Matt's point, we're just a small component of what that looks like.
Excellent. Thanks a lot, Silas. So our next question is from John. Regarding hiring of technical folks to support automation, we at Corning CC are trying to get a 2-year mechatronics AAS program going. Which skills would you feel are most important to teach? Who would like to start with this question?
I can certainly chime in that I think the ease of use that's associated with collaborative robots themselves, it opens up a lot of different resources within a lot of facilities. So the robot itself, the programming is pretty straightforward. We offer lots of training courses across the country ultimately so that we can get you pretty dangerous on the robot side of things fairly quickly. So I think just the ease of use alone opens up quite a few doors to whom you can hire in to work with those robots.
Excellent. Thanks, Silas. Anyone else want to add on to that question before we go to our next one?
Yeah, I mean, I can just say, like, I think a commonly overlooked piece of manufacturing education is metrology and quality control. If you can lay those foundations of really good quality, understanding what it takes to, keep that manufacturing process running as it should and producing quality parts. I think, having those foundational skills is certainly important for students to understand before they get into manufacturing. Because if they don't understand that as a core principle of manufacturing, there's going to be a lot of hiccups along the way, and learning to do probably at the wrong spot. It'd be better for them to learn about that in school rather than on the job.
Excellent. I appreciate it, Stefan. Thank you. Before we get to our next question, this is actually going to be our last one that's currently in the queue. So I encourage the audience, as you're listening to all this, what questions come to mind for you? Please don't hesitate to type them in. Again, if we run out of audience questions, the panelists and myself have questions prepared that I am fully ready to use, but my preference is to hear from you. So the next question in queue is from Jeff Richland. I've seen many smaller companies purchase robots without really understanding what it takes to make a system successful. And Matt kind of alluded to this a minute ago. Failure is common. What resources are available in downstate New York? Given the fact that I am not from New York and I'm not in New York right now, I definitely cannot answer this question. Who from our panel would like to take a stab at this one?
Sure, I can kick things off. Sure, I'll kick things off. Hey, Jeff, that's certainly a very good question. There were a lot of early adopters within Universal Robots going back many years that you think about the ease of use associated with collaborative robots, and they are very easy to use. But then when it comes to bringing that full circle into a fully automated cell, that's where resources have been up and down. So we offer a lot of different training on the robot itself within our office in Long Island, New England. We have a lot of partners as well that offer UR training. But part of my role within the organization is to continue to nurture and grow our systems integrator partners that can provide full turnkey systems for customers and be an additional resource for our end users. So that's an area where I'm always happy to help out, is to make some partner recommendations and also continue to support our systems integrators.
Yeah, Brian, I might weigh in on this one as well. And I'm going to put in a shameless plug for your local manufacturing extension partnership center. So if you happen to be in Binghamton, if that's what you mean by downstate, I'd definitely reach out to Carol and AM&T as a starting point. They work with Buffalo Manufacturing Works and can help you sort of focus in on what the key issues are and help you de-risk the process by bringing in somebody like Buffalo Manufacturing Works who can probably do a project, help you understand what the key parameters are, what the best technology solution might be given what you're trying to achieve. I should have mentioned earlier in the program as well that these MEP centers often have access to grant funding, especially through organizations like National Grid and NIST that are very flexible and easily accessed to do some of that technical support work.
Excellent. Thank you, Ben. And then also of note, there are several other MEP centers in downstate New York, TAC and MTRC, that can definitely be contacted in support as well. A few more questions just came in, and we have about 10 minutes left in our panel. Next question is from Mark Kupferberg. What resources are available for AOI in electronics, parentheses, PCB assembly? Anyone like to take this question?
I guess I'll jump in and say I don't have a good answer, but I've definitely seen people struggle with this one. And I'm assuming you mean optical inspection there. You know, what we have found in the past, and we have not done an exhaustive look in this, like we've tried to identify are there good ways to do this with, you know, off-the-shelf technology, whether it's with a robot or just like a small, you know, workstation inspection system. There are some things you could do, right? You could build, you know, pretty cost effectively a small system that you could just put on a workbench and slide boards through and have it tell you if components are there or not there and what's missing and what's wrong. But I know the last time we kind of looked down this path, in the end, what we came up to was the kind of solutions for that industry, for the PCB SMT industry that were available were probably the best solutions, right? There wasn't like a clear line of sight to, hey, this is what the PCB industry uses and we want to find a better way to do it. Those solutions seem to be pretty good, pretty cost-effective solutions already. So I know it's not a great answer for you, but it might be one where you want to kind of see what's already available in that industry, because there is some purpose-built stuff that already does that.
Excellent. Thank you, Matt. Anyone else want to chime in on this question before we move to the next one? Okay. Next one comes in from John Gilmore. Anyone have any experience in using a discrete modeling platform like Simio to simulate a manufacturing space, particularly in high mix, low volume manufacturing? Any implementation tips? Andrew, I know currently you mentioned your high mix, high volume, but I'd like to throw this question in your court first, seeing if you have any modeling platform experience at BorgWarner that you can perhaps share with the group today.
Okay, great. Thanks, Brian. So interestingly, we actually don't. So in a recent acquisition of Delphi, we did, they have their own proprietary modeling software that I just got an introduction to here in the last few weeks, because this is going to become more of an issue for us as well as our service requirements continue to extend out for the auto manufacturers. So we will have sections of our manufacturing floor that are going to be lower volume, high mix. But unfortunately today we don't have any modeling software, and I personally don't have any experience that I can share with you.
We've actually done a little bit of this, Brian, and we've tended to use some very simple packages like Simulate. Our goal is typically to identify where your shop floor constraints are. One of the big worries we have, and I think this applies to implementing new technologies, is making sure that you're not doing what we would call a random active improvement. You may be able to approve a certain process, but it doesn't affect your overall output because that's not the constraint that you're facing. And these simulation tools can be a great way to identify where that constraint is on your shop floor. Where we've bumped into problems is trying to take that from a demonstration or an identification tool to an ongoing tool to manage your business. In other words, to create a system that's going to automatically help you manage all those variables. That very quickly gets complicated. There are certainly good tools out there to do it, but I wouldn't underestimate the amount of effort that takes and the understanding of your process that's going to be essential to make that work.
Excellent. Thanks, Ben. We just got a question come in from Chris Schillo. We're going to start posing this one to Silas and then probably ask a few other people on the panel to weigh in, given the fact that they're going to offer their own differing perspectives. So Silas, you'll be first up to bat for this one. How many hours of operation can I expect to see from a cobot before wear parts need to be serviced? And what would you estimate the annual cost for the upkeep of these arms?
Yeah, great question. Thanks for that one, Chris. The mean time to failures and that whole conversation is very subjective based on the actual application and what is being done. So one of the resources that we like to offer at Universal Robots is prior to a cobot deployment of a cell, we will look at installation files and the programs being run to make sure that all of the appropriate payload settings and center of gravity offsets and anything associated with the actual application is to expectation, and will also increase the lifetime of the actual robot itself. We have robots that are still in the field from 2013. We're on our 5th generation of robots. So we have a very robust platform called the E-Series that customers can expect, a decade or better out of, depending on what the application itself looks like. In terms of preventative maintenance, there's no oiling or greasing of the joints or anything else like that. You can change out your air filters in the controller annually if it's required based on what your system looks like and what your facility looks like. But outside of that, there's no regular PM. And about 80% of the failures that we see with our collaborative robots, we can troubleshoot those virtually and look through log files and programs and actually determine what is wrong with the robot from afar.
Excellent. Thank you, Silas. Andrew, Matt, and Stefan, given that you're all using robots in some capacity or another, I welcome you to jump in on this question. Who would like to go first?
Yeah, I can take a stab at it. So, we have a lot of robots, probably a couple hundred on campus. We have Universal robots, we have FANUC robots, and this definitely comes back to it depends, right? If you have a load on your robot that it's not really rated for, you're going to see those joints wear out substantially faster than you would expect. And we've personally done that, so I don't recommend it. But depending on, if you set it up right, we probably hold, 3 or 4 different joints in our general stores for the amount of robots that we have. We're seeing, 6 months to a year. Definitely the FANUC, you have to PM properly. So those you do have annual PMs that you need to do. So you want to follow those general maintenance procedures. So you can get a good life out of them. Again, I think it comes down to understanding and working with your whatever company's providing it on, hey, what is the load? How fast is this thing moving? Those are all inputs into what that life will be.
Excellent. Thank you, Andrew. Given that we have no more questions coming in, we have about 2 minutes remaining in our panel. Stefan, let's throw this question to you. And then Matt, if you want to jump in on the question after Stefan, that would be very welcome. Stefan.
Yeah, I mean, in terms of where, kind of as Silas was alluding to, it does depend on the application and payload. Usually since we're doing inspection applications, there's not as much concern with payload requirements and over stressing the robot. So, I'll just comment on, some of the peripheral stuff in the system, like as we're doing inspection applications, things you might need to recertify yearly would be, the gauging fixtures, the masters that you use in the system, like gauge blocks, ring gauges, things like that, getting those recalibrated. Those are kind of recurring costs that, you might do every 6 months, you might do every year. So there's things outside of just the robot arm that you should also think about that may need to be serviced on a, year-to-year basis.
Excellent. Thank you, Stefan. Matt, please.
I think like any other industrial, piece of equipment, things can wear out every once in a while. It's a lot about how you use it. These are nice. All the collaborative robots that we've seen require pretty much no maintenance, which is great. One, maybe what I'll add here that hopefully is a little bit helpful is the way you use it and set it up is sometimes a bit different. And where I see this is if we're working with someone that's used traditional industrial robots for years and years and years, and this is their first time using a collaborative robot, there's certain things that they view differently, right? And the way collaborative robots work, what they sense, what they monitor, the safety aspects require that, in some cases you have to be a little more thoughtful in how you set them up, especially making sure you set the payload correctly and things, right? So if you're telling your robot that there's nothing on the end of it, but it's lifting a 10-pound weight and it's moving around, right? It's not sending the right current to all the joints, and inevitably that's going to wear things down faster than they should. So if you treat them right and, follow those kind of guidelines, you should be fine.
Thank you, Matt. And so actually we are 1 minute past time. I'd like to thank all our panelists today. Appreciate everyone's perspective. And again, a quick reminder, we're about to go into networking and a lot of opportunity for you to speak with the panelists directly over the next few hours. So if you didn't get a chance to jot your question down, or you want to get a longer answer and have a greater discussion, please do seek out the panelists. I'd like to thank Matt, Andrew, Silas, Stefan, and Ben for their time this morning. I'm going to hand it back to Everton. Everton, thank you.
Thanks.
Brian, Matt, Stefan, Brian, Silas, Ben, and Andrew. This was very, very informative. Excellent job, everyone.